Hello everyone, I'm Ricardo. I'm from the University of Florida. I'm part of the Human Centered Technology and Construction Lab, and I'm here to talk about our research. But before I talk about the title of our research paper, I wanted to share with you what are the elements and how we came up with that title. So let's start with what are 360-degree panoramas. So 360-degree panoramas are, sorry about that. I think I overclicked. Oh, there we go. 360-degree panoramas is a novel way to capture everything that surrounds us using photography and videography. With this technique, we are enabling a sense of place and a sense of immersion within the job site, which is perfect for the construction domain, as a lot of data is required to gather an accurate representation of a job site. But what I'm showing here, it's only what these images are capable of. We can augment these images with layers of information. And in order for us to do that, we included an interactive element into it. And that's why we called it 360-degree interactive panoramas for construction sites. And what we did was overlay data of information with this. For example, here we can see the energy coefficients for a window. We can see a cross-sectional window. We used images and text to augment the 360-degree panoramas. On the second one, we'll be able to observe in a minute how the installation of an HVAC pipe is done and what is the flow that goes through that pipe. We can also see how the images are linked and how we can navigate them. And we can also add data for web-based content, which, for example, here we're referring to this ladder, which we can see the height and as well as the load rating. Other elements, such as georeferencing, the location that within the job site with a floor plan can be displayed, but there are many other augmentations that we can use for the 360-degree panoramas. So now that we know the elements of this is how we put together the title for our paper. So we use 360-degree panoramas, we use construction sites, and we use interactivity to create using 360-degree interactive panoramas to develop virtual representations of construction sites. But before we go into the development, how we created this interactive panoramas, I'd like to take a step back and look at what previous research has done. And what we found was that at the very beginning, all the authors were interested in looking at how these images were created, how they were captured, how the interactiveness came into be for this type of images. So the first one that we found was Finch and Wink, which what they did was they related traditional images to a floor plan, and they created a navigable construction site. Subsequently, May and Wink, what they did was to create a robot that they could capture automatically panoramas with it, and then implement it in their old system where they could link all the images to a floor site. And then Dickinson took it a step forward, and what he did was to include those panoramas into a web-based platform where they could link the information within the panoramas, additional information, and it could be shared with everybody through the web. More recently, Code et al., what they did was they used the 360 panoramas as a background drop for 3D models. And Ghezari et al., what they did was they implemented BIM models with information into the 360 panoramas. So as we can see, there's an affinity with virtual reality. So why do we want to do interactive panoramas versus virtual reality? So in these two images, we can observe that the traditional VR techniques and the 360 panoramas, we can observe the same amount of things in them. The issue with the traditional VR modeling technique is that it's really computationally expensive. Not all computers can use them. The bigger the project, the more expensive it is in terms of computing. Also, the quality rendering capacities of the computers is limited because it's still a digital model. Moreover, it's time-consuming. It requires a set of modelers to develop the project. And inevitably, those modelers are human. So what they model is what is perceived by them as the reality, which might not be 100% accurate. On the other hand, 360-degree panoramas have low computational requirements because they are in a format of images or videos. And they're non-computer generated, so they represent the actual reality. That's the same goal that we have with unmodeled view of reality. That it's true reality what is represented to these images, and they're very easy to capture. So the time to model the whole job site, it's much less. So now that we know why, let's take a look at how we created this interactive panoramas. For the interactive panoramas, we have 4 steps: capturing, authoring, immersion, and distribution. The first step is capturing, and for this one, if we want to talk about capturing, we have to talk about traditional DSLR cameras versus wide-angle lenses cameras. For traditional cameras, we have to either use automated rotating platforms or camera rigs, where we can capture a row of photographs and then put them together in an output, which creates our panoramic image. For fisheye lens and catadroptic cameras, we create an already distorted image, which requires less amount of images to create our output. For the catadroptic cameras, what we capture is the reflection of a curved surface, and from the fisheye lenses, we create a distorted image from the lenses that are already wide angle. And that takes us into our second step, which is the authoring. How do we put together those images? And to put together those images for the traditional cameras, we have to rely either on manual stitching or software processing, which what they do is an algorithm projection for cubical, spherical, or cylindrical, and there's many other projections, and they create a distorted image out of that. For fisheye and catadroptic type of cameras, this process is much simpler and it's less taxing on the computer because the images are already distorted, so they only have to adjust the projection and stitch the images. As we can see on this one, the stitching lines are present, so we can see that there is stitching going over there, but it's very visible. For our study, we considered the amateur range for cameras, and we decided to go with the Ricoh Theta S because it's cheap, it's reliable, and it's easy to work out the workflow of the camera to create the distorted images, so we decided to use that for our study. The next step is immersion. In this step, we add all the elements that we showed in the previous video to augment the panoramas: text, images, web content, panorama interconnections, graphical user interfaces. To achieve this, we used a piece of software called Color Panator, and with that software, we could implement all these augmentations in the distorted format. Which also, this piece of software also helped us to do the next step, which is the final step of the interactive panorama creation, which is the distribution step. And the idea of this step is to be able to share it with everybody at the project site. And the best way to do this is doing it through a web-based platform. So we can export those augmented models as HTML models, and then we can share it in different formats, from computer screens to mobile devices to head-mounted displays. So now that we know how to create it, we wanted to do a pilot study to test this in reality. And how we achieved this was that we went out in the campus of the University of Florida. We selected a building that was under construction. This was a new engineering building for the chemistry department. And what we had as an objective was to visualize the building components with this technique and to document work, tasks, and situations that happened during the construction of the building. To achieve this, we used our 4-step process, which we took our Ricoh Theta S camera into the job site. We selected several locations where we could create a path, so we could create a tour within the job site. From those, we took the camera, we placed it in the different spots, and we captured the images. We captured over 42 images and 9 videos, and those were automatically stitched by the camera, which is very convenient because the post-processing, it's only doing the augmentations. So we obtained over 42 images and 9 videos, and we only selected 3 of those to keep it simple for the pilot study. And then we did our immersion step where we added data over the pictures. So we added text tags, we added navigation arrows, georeferencing, local referencing within the floor plan. And another good, nice detail is that you can compare the generated model views with what you're looking at into the BIM models with your panoramic images as well. And the final step is that we took that into an HTML format and we placed it on the web so everybody could look at it. And that is, I can provide that link later. Finally, what we obtain is what I showed you before, is this video where this is navigable. So if you go into the website, you can navigate through this and observe different elements. So text, it's really good because you can display information, images accompany the information displayed on the text. We can navigate, so we can go back and forward between the images. We can see different elements, and we can also add web content, which is very relevant because we can add video to that. We can add tons of information from the web. And another nice detail is that on the floor plan, you can actually look at the direction that you're looking at. Since this is a 360-degree panorama, it's interesting to know the reference point that you're looking at so you can be better located within the job site. So what we got out of this study? So we concluded that interactive panoramas are a low-cost, high-quality, immersive experience. They're suitable to visualize construction job sites since they're true to reality and there's no need to actually model the job sites. We also figure out that capturing is really, really simple. You just have to press a button and it will capture the images. It will stitch in for you and you get an output which is a distorted image which you can work with. And that all sorts of human-computer interfaces can be used to interact with the images. It's especially interesting to do it with head-mounted displays because it gives you a really good sense of immersion in the job site and you can rotate around and see things in a first-view perspective. And from our pilot study, we learned that the technical and practical side of this is very feasible, that the data is simple to capture, and that we can easily create navigable job sites. Finally, for our further study, we propose to do this in a larger study type of situation where we can collect more data and we can look at how people want to capture different stages of the construction site. Additionally, we want to test the data augmentations with actual users. And we want to look at a deep comparison between VR and panoramic imaging so we can have a better idea of what are the venues to apply each of the two different methods. Thank you very much for your time. We have about 3 minutes for questions. Yes?